Hi, so today we're going to be looking at problem number 5 from Leetcode called longest palindromic substring. Problem is as follows. You're given a string and you're trying to find the longest substring within that string that forms a palindrome. So in the example given below, we have BAB, AD. The output could be one of two. It could be BAB or it could be ABA, right? Both of these are substrings of size 3 that are palindromes. Recall that a palindrome is a string that is read from forwards to back the same as it is backwards. So same thing for example number 2. We got CB, BD. Output would be BB, right? Constraints here is that the length of the string is up to 1,000 characters. So how would we go about and solve this problem? I think there's two ways that we could potentially solve this. First that I'm thinking about is brute force. So here we can just check every single starting and ending position for all substrings within the input string. For each of these substrings, we can simply check if that substring is a palindrome or not, right? So this would be n squared because we would be checking every single start and end position, right? So that requires n squared, plus a palindrome check, right, on each substring. Second way that I can think about solving this is a little bit smarter, right? And here we could simply check the middle index of the substring. So in the case of this first example would be going outward. So let's just suppose we're looking at the letter A. We could simply have two pointers, one pointer going to the start of the palindrome. So that pointer from A would go to the B on the left, and then another pointer, J, that would go from A to B on the right, right? And that we could essentially expand outwards, right? The tricky part here is that there's essentially two cases to check, right? So the case that I mentioned here that we walk through would be a case of where we have a element in the middle. So this would be an even-sized, an odd-sized palindrome rather, but the other case is for even-sized palindromes that we need to check. So let's go ahead and let's code these two, right? Of course, the advantage of the second one is that it's much faster, just requiring a single pass on the string, whereas the brute force will require two pass, basically n squared. But I think for the given constraints, up to 1,000, we should be fine even with the first approach. So how do we code that? Let's start by coding the first approach. Right? So first, brute force approach. Well, first thing we need to maintain track of is this longest palindrome. So when we initialize a variable called longest, which will be empty, right? Now we're gonna check for every starting position, right? Range len s. So this is for every starting position. We're going to have to check every ending position as well, right? Every ending position. So for j in range len s 0 -1, right? -1, right? So this is basically we're starting from the end and we're shrinking the search space. If j minus I is smaller than or equal to the length of the longest, we break, right? Why is that? Basically, the substring we're looking at cannot possibly be largest than the longest because the current longest is already larger than the substring that we're looking at. Else if, right? So elif, well, let's take a look at the substring in question. So that's from S from I to J. That should be equal to the reverse of that, right? So this is, let's check if S from I to J is a palindrome or not, right? So this is S of I to J, and then this would be just it reversed. So those two should be the same. If that's the same, then we have a palindrome, then we have a palindrome. So what do we want to do? Well, we want to change our longest to be S of I, J, right? Okay, if we execute all of this, we can probably just return the longest. Let's run. Let's see if what we get. Looks like we have some kind of error here. Let me see. Oh, yes, of course. Yeah, it's right here. Range lane S 0, 1. Okay, I think this is good. Oops, sorry. Yep, that's not quite. There you go, right? So that looks good. Let's submit. Let's see if it actually passes, given the constraints. If it doesn't, we also have a second way of solving this problem. But I think given the constraints should be fine. Yeah, so as you can see, we do, it is accepted, right? So it does pass. But of course, it's not very fast. So, that's the problem. So how can we make this faster? Let's talk about the second approach, right? So as mentioned, second approach here, we'd be looking at two cases, right? Basically the even case and the odd case. I think it will be important for us to define certain helper functions. So maybe we could, so the idea here would be, would pick the midpoint and would expand from that, right? So why don't we first handle the even case, and then I believe handling the odd case should be trivial from there, and then we can actually code the longest palindrome. So let's handle the even case. I'll call this expand median even, right? So this is expanding from the middle from for an even palindrome sequence. Self S I and J, right? Why I and J? So I and J would essentially be the two even points that would be expanding. So from this example of example 2, I might be, the first B, and then J might be the second B, right? So let's first code some of the base cases for this. I being smaller than 0, I being smaller than 0, or J being larger than or equal to the length of S. And here what we want to return is simply, I plus 1 J, right? I plus 1 J. I think we need this. Reason for that is, essentially we ran out of space, right? So what cases would we kind of run out of space? Case of a single character, right? A string with a single character and so on, right? So the other case here is that I can think of is essentially if S of I is not equal to S of J, right? So meaning the two characters that we're comparing are not equal. So in that case, we just don't have a palindrome. So S of I, not equal to S of J. In this case, no palindrome. So let's just return the empty string. We cannot even return some kind of substring here because it's not a palindrome. So for this, we're going to have to then iterate outwards, right? So what I'm thinking is we can decrement I and increment J if both S of I and S of J are the same, and we can continue doing that. If they're not the same, what we can do is we can simply return the smallest substring, right? So how would that look like? So I smaller than or equal to 0, and J is smaller than the length of S, right? So while we're still within the bounds, we can continue iterating. Exactly as I mentioned, as S of I, if S of I is equal to S of J, then we can decrement I, right? So that's I minus equal to 1, J plus equal to 1. Else, they're not the same. We can simply return the smallest substring so far. So that would be I plus 1 all the way to J, right? Else, we can simply return, so if we exit all of this, that means that the entire string is a palindrome. The entire string is a palindrome. Then we can go ahead and simply return that entire string, right? So that'll just be I plus 1 all the way to j, right? Cool. So that should handle the even case. Now let's handle the odd case, right? So expand, median, odd, self, s, and in this case we just take I, right? So because we're expanding from a single character, we don't need to expand from two characters, right? Now this can simply be, so any substring of size 1 is a palindrome, so we don't even need to check that, right? So we can actually just handle the odd case by leveraging the even case, right? And the way to do so is like so, right? Is expand median even, right? Expand median even. Of course, we pass s, I minus 1, right? And then I plus 1, right? Why would we not check I? Because, well, any character, single character, is a palindrome by definition, right? So we don't even need to check that. That should be handled by this case right here. So we can simply just expand anything around that character, right? So that should handle the odd case for us. Now, let's actually call these functions so that we can solve the problem, right? Again, just like in the first example, we're going to need to keep track of the longest, right? So why don't we call it the exact same, right? Longest. Now, for every point within that substring, I'll call it I, right? We want to be expanding it as if it's an odd palindrome and as if it's an even palindrome, right? So for every midpoint, we can think of it as this, right? So range, length, s, right? I'll make a comment here. For all of the midpoints of the palindrome, length s, we will check if we can expand the even case, right? So if I larger than 0, we can expand the even case, right? Otherwise there's only an odd case, right? So why don't we create a sub essentially a current palindrome, right? So this would be self dot expand median even si minus 1, oops, minus 1 I, and yeah, and then of course we have to update then the longest palindrome. So if len of my current best palindrome is larger than the length of the longest, right? Then let's update the longest to be the current, right? Now we'll do the exact same thing for the even case, right? So what do we call it? But the even case, there is no condition, right? Well, we can always run the even case, right? So this would be if current self dot expand median odd, right? I believe I called it that, si. If and then same thing as before here, right? So we can just update the longest, right? Just copy paste this. Okay, now at the end we can simply return the longest, right? Okay, let's take a look. Okay, for I in range, right? That's what we're missing there. Okay, maybe we do need maybe there might be some precedence in the operators here, which is why we need this. These braces. So let me just add that to the solution. Oh, yes, of course. S is missing. That's the problem. I don't think it's the braces. Okay, cool. So we got BAB, AD, we got BAB. Second one, we got CBBD, and we got BB. Let's submit. Let's see if it actually passes all of the test cases. And yes, it does. And as you can see, Much faster than the solution before. Well, thank you for watching, folks.